Thank you very much, Juan, for giving us this very nice panorama of many things which have been happening in all these areas and in their connections. So normally, what I do here normally is to start asking questions myself, so that people can reflect on your talk and they, can get warmed up to ask more questions. So I will start with. I know that you started your scientific career working on data warehouse in the end of the 90s, right? I would like to ask you, to tell us a little bit about your personal trajectory. Why you decided to work in this area? What made you interested in data warehousing in the beginning, and in particular in taking this kind of more doing object-oriented modeling of data warehousing in the end of the night. What got your attention and your interest to work in this area?
Okay, thank you very much for the question, because it reminds me in my starting, when I was studying my PhD. Actually, the beginning was where of course I didn't know anything about data warehouses well, and I needed my first year at the university, I had to prepare a course about data warehouses. Okay, of course, when I was preparing the practical assessments and I was preparing everything, I was from the database design. I was a database designer. Okay, and then I realized that the way we were doing things, we are so not so procedural, no methodology. So I had problems say, okay, I'm sure that there is a way why we had entity relationship model for transactional systems, why we had tools to draw a transaction, an entity relationship model, and then we click on and we generate the logical model, and why in data warehouses and BI applications, we have to design the logical model from scratch, and I didn't have anything to consider user requirements, to consider the main issues that I should consider in the final application. I was straight to the logical implementation of data warehouses, and then I started to have the curiosity and started to read if there were some approaches. And this was because I started my PhD at that time, in 1997, 1998. So I realized that at that time there were no conceptual modeling approach for data warehouses, and then that's why I started in researching in that area.
I'm glad you did that, Juan.
Yeah, absolutely. I don't know if you call, of course, there was a kind of lack in the sense that I faced up with the problem of implementing logical data warehouses or data warehouses from the logical point of view with no other help. And so I wasted a lot of time, and I wanted something, as I was doing in transactional databases, I wanted something to help me from user requirements to the implementation.
Nice. So moving from data warehouse and business analytics to machine learning, right? To complex predictive models and so on, which kind of mirrors what's happening to the area as a whole. And then, it seems like a smooth transition, but there is a very big change, right? One is about, so the former is about giving business experts ways to formulate questions that allow for business insights. Predictive models are, giving machines the role of having insights about the business in a general interpretation of the term. So, that changes quite a lot the role of conceptual modeling in this transition, right? So, I wonder if you could comment on that, on how conceptual modeling will change as we move from business analytics and data warehousing to complex predictive models.
Yeah, very, very interesting question. And actually, I don't know if I have the right answer yet, honestly, because it is too recent that we've been researching for the last 2 years. We've been working on using machine learning from conceptual models. So up to now, what I can tell you is that I want to model, for example, that some final users want to know what is the percentage that some patient from a radiography is going to develop cancer or not. Okay, so I model in several scenarios. I still model the user needs, but there are some scenarios, like mainly, for example, in the health area, where you don't know exactly how to respond to that question. You have the goals, you have the question. So someone, for example, now I'm working in a project for the COVID. I'm working in a project with a hospital that they want to know, of course, what are the different aspects influencing that a patient suddenly change from one state to another. I mean, now they know that a patient is good, and in 24 hours probably go to the special care, and in 48 hours is dead. So they want to know exactly what are the changes. So you can model, of course. Well, I have plenty variables. They may have an intuition about the variables, the more relevant variables for modeling, and they want to model the changes, the state changes of patients. But we don't know exactly which variables we need to take for that answer. In traditional BI, when I have a KPI formula, I go to the data sources, and of course I'm sure about the variables, influencing the variables that I want to use for measuring if I want to achieve 10% more of sales. But in several problems, I'm using ML to help me find out the more relevant variables. And of course, ML algorithms are a black box. You don't know what's happening inside, okay? So that's why the idea is, okay, I have to believe in the output of the ML. If they tell me that these 10 variables, for example, are useful or have 90% of credibility of trustness for something, these are the variables I'm including in the KPI. So up to now, what we have done is that investing on how, for several scenarios, we can combine the KPI in the way how to choose the variables, the right variables to measure something.
Very nice. One thing I like very much in this approach, especially the work you did in collaboration with John and others in connecting KPIs with goals. I mean, this is something that I see happening more and more. The connection not only with goals, but data only has value as it connects to human values, organizational values, and organizational risk. So the connection between data modeling on one hand and things like value modeling, risk modeling, trust, and also the approaching things like fairness, transparency, explainability, and so on from a modeling point of view, right? So people are dealing this with a kind of ad hoc solutions for now, while I feel that we should invest more in developing modeling techniques that would allow for formally connecting data modeling with trust modeling, with transparency, with value and risk, and so on. So can you elaborate on that, if that's, in your view, the next step, after modeling goals, modeling all these other type of phenomena?
Okay, this, of course, I completely agree with you. This is a very hot topic nowadays. To be honest, we have not yet considered TrustNet on or the issues that you have mentioned now, because we are now pretty much focused on how to use the ML to enrich the way we calculate KPI. But I completely agree with you. I mean, this happened to us 10 years ago when we extended our conceptual models by including several non-functional requirements, and they were very useful in considering not only functional but also non-functional requirements. So I guess that you are completely right. Several hot topics are around considering other features, trustness mainly in this area, and if we are able to have conceptual modeling approaches combining both of them, that would be very, very useful. I completely agree about what you're saying.
Mm-hmm. Another area in which I see, people connecting more traditional data warehouse modeling and so on approach to is these areas of, connecting to semantic technologies, right? I know you did some work on using RDF Data Cube, and also you mentioned the use of ontologies for KPI selection and reasoning. So I wonder if you could elaborate on this, on how do you see the connection between more traditional, these more traditional data, multidimensional technologies and semantic web technologies?
Yeah, well, this is something that we wanted to test, honestly, to say, okay, the hypothesis was we are able to define KPIs from raw data. Okay, we have all the procedures and all the methodology to define KPIs from raw data and through our goal modeling approaches. The hypothesis was, are we able to define more concrete KPIs if we have a semantic layer on top of the raw data? And the answer was that yes, we were able, by using ontology and by using ontology reasoning, we were able to achieve more concrete KPIs than if we didn't use ontology. Actually, Giancarlo, and you are an expert on ontology, we are working on a wider methodology because we, as you have seen in the presentation, there is one work, but we are currently working on two works where we want to provide that more methodological approach for incorporating semantics. So absolutely, my experience, Giancarlo, is that the hypothesis was true. I mean, we were able to define more concrete KPIs by reasoning on ontologies, more than if we didn't use them.
Very nice.
This opens another research topic again.
Yes, so it's quite exciting. It would be nice to talk about this offline afterwards.
Yeah, absolutely.
Now, turning to big data a little bit, I think it's pretty clear by now that the problem is not velocity or volume, but it's variety, right? Heterogeneity and multiplicity of data sources and so on. So people spend like 99% of their time dealing with that, with finding data source, cleaning data, integrating, and so on. So I guess ontology, in the more conceptual sense, would play a role there as well, right? On the other hand, how to do this in scale, right? So if you have, cases in which you have lots of data and lots of data sources, how to approach that?
Yeah, that's the problem with big data. I completely agree. When I talk now, thanks for your words, because when I talk now about big data, I say that the current problem is variety. It's not volume, it's not velocity, it's variety, the variety of data. And of course, the variety with a huge amount of different data sources. So it's a problem how to integrate, how to deal with that variety. So we have to do pre-processing of the data sources. And of course, you are right. I mean, the problem is that, and you are an expert on ontology, you've been able to work with domain ontologies, okay? You've been able to define ontologies in order to be able to later on reason on ontologies. But the problem is when you are dealing with new data that you don't know anything in advance. And you need to make analysis, you need to incorporate that data analytics, okay? So it's absolutely a problem how to integrate the huge variety of data. And you are more expert than myself, of course, in ontology. I can tell you that I have used ontology in two works, and I use them. And well, it's a promising solution, okay? It's promising how we can combine both approaches for big data. And the problem with big data is that, okay, from the theoretical point of view, you may provide a good solution, but then you need to go to projects. We are in the area where we need to test everything. And when you go to real world projects, you face up with the rapidness of processing the data, the real needs of data analytics. Sometimes you have to do in-memory analytics, and you don't have time to define an ontology to process to. This is the problem. Okay, from the theoretical point of view, it's good. This is what we need to research as well. But then you are right. When you test in real scenarios, sometimes you need to do things much quicker than you are able to.
Yeah, I mean, it's very hard to imagine that we're going to come up with completely automated solution for dealing with integration and cleaning, right? I mean, because data cannot tell signal apart from noise, so you don't know if the data is dirty. Data cannot know if the data is dirty, right? But one thing that might happen is if we have a good selection of mappings, which are very well designed, you could extrapolate from that. So this could be an interesting direction. This is the direction taken, for example, by Mike Stonebreaker and his company Tumblr, right?
Yeah.
The
matchings, yeah.
Yes. Well, I mean, talking about Stonebreaker, another question I wanted to ask you is the following. You know, you were one of these people that always paid attention to technology transfer, which I find really, really great and extremely important. I think it's very hard for people to do research in data modeling and data management without paying attention to the real problems, right, that practitioners face. So, I mean, the question I wanted to ask is about this, about the importance of technology transfer, but I will ask a more general question. You know, this just came to me thinking about Mike Stonebreaker. You know, when Tadcock proposed the relational data model, it was kind of a crazy idea. It was genius, this idea of thinking about data manipulation in terms of set theoretical terms as opposed to more procedural terms. But people back then, you know, thought that this was too complicated first to understand what that thing was about, and then even if people could understand, it was too hard to actually implement in an efficient way. And even if they could do it, it would be impossible to teach to COBOL programmers how to do it. And one revolution there was these guys, Mike Stonebreaker and Eugene Wang, implementing the ingress. So, and they did it because they were following other people's work, and they were busy with that for years, for 5-6 years, trying to make that really work in practice. So my general question, so I'm asking you this question about the, you know, not having too opportunistic goals and having goals in the long run, right? That to really make things work in practice, but really have output from people, you know, for when the rubber meets the road, and really understanding the requirements that people have in practice. What is your experience on that? On this research that it's not only of excellence, but also of relevance from the point of view of practitioners?
Yeah. Okay. Thank you for your question. It's very, very interesting. Well, I can tell you about my own experience, and I have to be honest. Okay, I was able to pay a lot of attention to transfer technology in the last 10 years. You know why? Because if you go back to my presentation after 20 years of researching, first you develop one conceptual model, and then of course you develop a set of experiments with users to see, okay, what about the understandability of a model? What about the understandability of a conceptual model? We have made several experiments in companies to say, okay, we have this conceptual model. Can you please have 1 hour of experiments to see if you can understand the model, if it's useful for you, and blah, blah, blah. But then it's just one model, okay? So you can test one conceptual model, you can test one approach. But it was only after, let's say, 15 years of researching when we had not only conceptual models, but also the whole methodology, the whole procedure to cover the whole data value chain from the beginning up to the end. When we started, because if you go to companies, you need to cover the whole data value chain, and this has been able for us when we had all the different modeling aspects in the different parts of the data value chain. Because if you are involved in a real world project, you can not only say, okay, I have this conceptual model for the data warehouse repository, please draw and what else? What else? How do you connect with the data sources. How do you make the traceability of a problem? I change the data source, and then how can I change the element? How can I generate the dashboard, and blah, blah, blah. So we were only able, Giancarlo, after being very conscious about what was the data value change from the very beginning up to the very end. And when we were ready to have models for covering different aspects is when we started to worry about technology transfer. And then in reality, if you go to companies and you and now, of course, any approach, as we also have companies that we are working in a very tight collaboration. Now, when we have one new model, when we have one new approach, we can test in real projects, but because it's one other piece of the models that have already been tested in that scenarios. I think, honestly, that we need to, this has been always a kind of discussion within our researchers, okay? Conceptual modeling. Practitioners consider that conceptual modeling is out of fashion and is nothing for them. So, but if you show that from a conceptual model, you can generate things that not only save time and cost, but are more focused and more tailored to the final user needs, is the time when they see that conceptual modeling is useful. Otherwise, and in big data also, you go straight to data, you go straight from data, you process data, you want to put the data on a dashboard, you want to put it for quick analysis.
Juan, I'll move now to the questions from the audience. So the first one is, what research hypothesis suggestions would you give to a PhD student who wants to investigate the impact of foundational ontologies on machine learning?
Well, from ontology foundation of machine learning. Well, I don't know if this question is more for you, that you are expert on ontology foundation, being honest, okay? Because thanks for the question, but what I did is to define the hypothesis is that an ontology, of course, can give me more semantic information that from the ontology reasoning, I can derive more tailored KPIs. But if this question is more about the theoretical foundation of ontology, I should co-advise that PhD with you, Giancarlo, because you are the expert in ontology foundation. So probably you may give another more answer than myself.
That will be a pleasure, Juan.
Right.
The second question is, how do you validate your machine learning models?
Sorry, so how?
How do you validate your machine learning models?
Well, with domain experts. Well, I mean, I train with the data according to what I have modeled. I train the model with the data, and then I go back to the domain experts, who is the one who needs to interpret the output of the models. Absolutely, this is the constant in the everyday data science projects, that you need the core interpretation of data because, for example, I mean, how would I say? Correlation doesn't mean same behavior doesn't mean correlation. Okay, I mean, if two variables behave on the same way, that doesn't mean that they are highly related. So a domain expert has to interact all the time. Absolutely.
Absolutely. So for the use of weak data, how were you able to interrogate weak data to distinguish concepts from individuals? Since in weak data, they are represented in the more or less the same way, right? How do you tell apart types from individuals on weak data?
What do you really need talk about weak data? Are you talking about weak data about data that is not present in the main goals of the analytics?
No. You mentioned that you did some work on weak data. like on Wikidata behind Wikipedia, the data structure behind Wikipedia.
Wikipedia, you mean?
Yeah. So
Oh,
the data structure underlying Wikipedia, right?
all
Weak
right. Sorry.
sense, not weak as opposed to strong.
Yeah. Okay. Okay. Sorry, I understand. So the question, can you repeat the question about Wikipedia?
So the question is, when in your work with Wikidata, how do you distinguish, how do you tell apart individuals from concepts? Because they are represented in more or less the same way.
Yeah, well, we apply the algorithms that and we try to distinguish between the two set of elements. So we provide association rules and we provide a classification and we give them the entrance. We need the input of that elements and then to select to let them work.
Okay, another question here. You consider a good number of models layered according to the flow of work. That means you use a model suite. Remember, suite is a sophistication of ensemble. So you use a number of models together, right, in different languages. So models in this group of models, they must be coherent, if not consistent. How do you manage to support the coherence of all the models that you put together? For example, can the KPI model conceptually conflict with the analysis model? So how do you guarantee the consistency of the set of models that we employ together in your work? That's the question.
Okay, well, the issue here is that from the very beginning, we use meta model based on the same modeling or meta modeling approach, which is UML. Well, so all the meta models have the same pattern, if you allow me to say that, in the sense that when we build one model, we are using or we are taking the stereotypes already defined in the model and we add new stereotypes. So I think, of course, the one great advantage is to be able to use always the same meta modeling approach. Okay, we have not used ER or UML or semantic models or different models with different meta models. I think this could be the problem, to use a different meta models. But as long as you use the same paradigm and the same modeling language, I believe that you can do that. For us, it's not a real difficulty in doing so.
I guess the question also referred to, let's say, conceptual consistency, right? I mean, the meta model would guarantee some sort of syntactical interoperability, but do you experience any problems, I mean, in practice of trying to put this language together in a way that you have also some sort of semantic interoperability? Not talking about real world semantics now.
Well, yeah, honestly, I mean, honestly, some when you, for example, the experience when you use conceptual models using or incorporating non-functional requirements, for example, I face up, of course, with problems in interoperability because you are considering non-functional requirements and then you are going to use them in applications where you face up with conflicts. Yeah, so it is that this is real world. You're right.
The idea of Go model is to provide the right requirements, right? So it's a question.
Sorry,
GQ,
it was cut and then it was sorry.
Oh, sorry. So the question is about Go modeling, right? So the person makes a reference to the Go question matrix, GQM, and asks what kind of Go models are you using in your in the case studies that you mentioned.
Yeah, we have been, as I said, we have been working in a tight collaboration with John Milopoulos and the well-known Tropos methodology, and we based on the BIM model, Business Information Model, that was created and led by John Milopoulos in the University of Trento. And then from that model, we are extending and using that modeling approach to define the corresponding KPIs and the corresponding goal for BI applications.
Okay. Well, let me ask you a final question. That comes from myself as well, just something that came to mind, right?
All right.
When I was talking about, Mike, Stonebreaker and Ingress and Postgres, one of the things in Postgres there that was, underlying the idea of the design of Postgres was this idea of designing a database in which you have this kind of growing block model of time, right? So you don't lose, you don't overwrite data, you just keep everything. And of course, one of the areas, there seems to be a new class of applications in which this is the case, in which data is a growing block, right? So you have event sourcing, you have account information systems, obviously, and you have a blockchain, which is one topic that I know Lucette mentioned in your presentation. So I wanted to give you a little bit the chance of talking about your work with blockchain, but also ask you if you don't think that we need to deal with that in the conceptual modeling level, to treat events and treat seriously events as first-class citizens in conceptual models, and deal with time in an explicit way in conceptual models.
Yeah, of course. This is the answer. Sometimes we need to model issues as first-class citizens that are traditionally considered as second-class citizens. This is the way. Sometimes you can model and you can provide conceptual models right for the applications such as the Progress project. Up to now, what we have used in the Progress is we have one transformation to generate the repository, the physical repository of data in Progress, as well as in any other commercial tool. And this is what we use up to now only, the data repository layer and the scripts. We generate the scripts that allow you to automatically generate the implementation of the data repository. But then you're right. Of course, you can, if you provide modeling other issues as first-class citizens, you may be able to enrich the way you can work with Progress. I agree.
There is a question that just arrived here. So which BI and machine learning were you using in the case studies that you mentioned? Which kind of software tools, I guess?
Well, think about that. We don't work in just one software tool. We are modelers, and as modelers, we need to gather user requirements, we need to model the real needs, and then we need to be able to generate the implementation in any commercial tool. Actually, this is the latest stage. I don't care if you are using a dashboard in Tableau, ClickView, or any other visual commercial tool, or I don't care if you are using IBM or Oracle or Microsoft or whatever. Well, as modelers, the last transformation is what kind of a script do I have to generate to click and generate the repository and generate the application. And actually, we are also working, and we have projects with Google Corporation that we are also generating cloud applications as well. Well, so the tool doesn't matter at all. It's like what I presented about visualization, about dashboard. I'm concentrated on the elements within a dashboard. I don't care about the commercial tool or the visualization tool that you want to use. As modelers, we need to worry about how to model something and what is the final implementation.
Very good. Juan, this has been really, really nice. I guess we have to wrap up, but thank you very much for, the generosity of being here, giving this talk, and answering all this question. Thank you very much. We really appreciate it.
Okay, Giancarlo, thank you very much to you for the invitation. When you told me, I thought, okay, it's a pleasure to be with you. Thank you indeed for giving me the opportunity to summarize you what are our main topics. And of course, if you any of the students would like further information, please don't hesitate contact us. And of course, what you said, we can talk offline about the data ontology approach for KPIs. Okay.
We'll certainly do that.
Okay.
Thank you very much.
Thank you very much indeed for your invitation.
Thank you again.